Hi, this video is on the Math0320 final exam review. I believe there are 25 questions on the final exam review. Let's take a look at some of them. Factor out the greatest monomial factor. Well, this is just like factor this out, factor out a greatest common factor. The monomial factor is what gets factored out. So it's the wording that might be a little different from what you're recognizing. But in other words, let's just factor out a greatest common factor. Let's look at the numbers 84, 126, and 42. 42, I can do 2 times 3 times 7, 6 times 7. 84, wow, is 2. 84 is 2 times 2 times 3 times 7, and 126. These are some big numbers. 126. I don't think they're going to be this large on the test. Divided by 2, divided by 3, divided by. So it's 2 times 3 times 3 times 7. Okay, so we need to find what numbers. I prime factored each one of these. Here's the circle the most: 2 2s, 2 3s, 1 7. So this is 4 times 9 times 7. Well, that doesn't make sense. What number divides into each? Oh, what's the greatest common factor? What number divides? Well, we know a 2 divides into each of those. A 3 divides into each of these, and a 7. So 2 times 3 times 7 is 42. So 42 divides into each of those. So I'm going to divide a 42 out of here. 84 divided by 42 is 2. 126 divided by 42 is 3. And 42 divided by 42 is 1. Okay, so we divided out a 42 underneath each one of these, and in the parentheses is what we got. Then when we factor out a GCF, what is the smallest power x that can divide out of each? 15, 9, and 6. So x6 divides out of each. If I divide this by x6, 15 and 6, you subtract the powers and you get x 9. 15 minus 6 is 9. Divide this by x6. 9 minus 6 is x3. Divide this by x6 and they cancel. Then the smallest power y's is y4. Y8 divided by y4. 8 minus 4 is 4. Divide by y4, you get y3. Divide by y4, and they cancel. So this is the answer if it said factor out this term, this expression. But it says what is the greatest monomial factor? And this is the monomial factor. What divided out? 42x6 y4 is what divided out. So this is the monomial, the factor that got divided out. They call it monomial because it's a one-term thing. All right, so we're just going to factor this. And when we factor, we always look for a greatest common factor. Do you see how a 5 factors out of both of these? If I divide both by 5, I get 4y squared minus x squared. So I factored out a 5, but now I have to ask myself, does the parentheses itself factor out anything on its own? And if you look, it's got two terms there. So when you factor two terms, there has to be a minus sign between them, and you have to make it look like this. Something squared. Well, I can put an x here. X squared is x squared. Up here, y squared, there's a y there, but how do I square something to get 4? And 2 squared is 4. So 2y squared is 2 squared, which is 4, and y squared. And then when to factor two terms, first you make it look like that. Then you put the 2y into the first spot of each. You put the second term x in the second spot of each. 1 plus and 1 minus. That's factoring two terms. If you're not sure about that, go back and look. You have to make this something squared. You have to make this something squared. We did that. Then whatever's in the parentheses that got squared, you put it in the first spot of each. Whatever's in this parentheses, you put the second spot of each. 1 plus, 1 minus. That's factoring two terms. Don't forget, there's a 5 in front. So this is the answer when you say factor this completely. That's what we get. Factoring three terms. The first thing we want to do is, once again, just like the last problem, always look for a GCF, a greatest common factor. I think 12 goes into 12, 12 goes into 144, and 12 does go into 84. So I'm going to divide each of these by 12. 12 divided by 12 is 1x squared. 84 divided by 12 is a positive 7x. And 14 divided by 12 is 12. So we factored out a greatest common factor. Now we want to factor this part, factoring three terms when the number in front of x squared is 1. Find all the pair that multiply to get 12. 1 times 12, 2 times 6, 3 times 4. And how to take one of these pair and add or subtract to equal the middle term, a positive 7. Do you see if I take the multiplication way and put a plus 3 plus 4, I get a plus 7. If I multiply these two, I get a positive 12. So those are my factors. A plus 3 and a plus 4 go in here. It doesn't matter which one's in which spot. And since we're dealing with x squared, we put an x and an x. And don't forget, this 12 is a greatest common factor. It has to go in front. So this is factoring three terms once you factor a GCF, a greatest common factor, out of it. Simplify, multiplying these two fractions together. In order to multiply these two fractions together, you have to factor everything you can. So I'm going to factor everything I can. Look at this 2x plus 8. Do you see how a 2 factors out of there? I can divide by a 2 in each one of these. 2x, do you see how a 2 factors out? So this factors just a GCF out. This bottom doesn't factor, so it stays like this. This x squared plus 4x factors. Do you see how they have an x in common? So if I divide both by x, I get x plus 4. So x times x plus 4 for this factor here. Now I just have to factor three terms, and I'm going to use the AC method there, 2x squared plus x minus 3. Using the AC method, 2 times 3 is 6. All the things that multiply together, 6 is 1 times 6 and 2 times 3. How do I get a plus 1 out of this? A plus 3 and a minus 1. A plus 3 and a minus 1 give me a plus 1. So this is called the AC method, where we split the middle. We get a negative 2x and a plus 3x. We use these numbers to split 1x into a minus 2 plus 3. This minus 3 comes down. This 2x squared comes down. Now we have 4 terms that we have to factor by grouping. Group the first 2, group the second 2. The GCF of this first group is 2x. When I divide it by 2x, I'm left with x minus 1. The GCF of the second group is 3, a positive 3. When I divide both by 3, I get x minus 1. When you factor by grouping, the parentheses should be identical. So now I'm going to factor out the x minus 1 in front. And what's left over is 2x plus 3. So this is the factor, 2x squared plus x minus 3 factors to this down here, x minus 1 and 2x plus 3. Okay, so step 1 is done. Factor everything, the tops and bottoms of everything. Step 2 is going to be cancel anything out, any top or bottom. Do you see how x minus 1 and x minus 1 cancels? I also have on top, I have an x plus 4, and on bottom, I have an x plus 4. Once everything that you can cancel, it cancels out on the top and bottom, then your answer is everything that's left. There's a number 2, and there's a 2x plus 3 on top. On the bottom, all we have is x. So there's the simplified version of what we just did. Okay, next problem. Same thing as the last, except this is a divide. So in divide, we leave the first fraction alone. Change the divide to multiply and flip the second fraction. Now we're going to do exactly, it looks like the last problem. We're going to factor everything we can. Let's do that. There's a 36, that's 36x. Nothing factors out of there. Here, do you notice a 9 divides out of both of those? And when I divide a 9 out, I'm left with x minus 3. This is the greatest common factor, 4x3 minus 12x squared. Do you see how a 4 and an x squared factors out? The lowest x is the x squared, and a 4 factors out of 4 and 12. When I divide this by 4x squared, I'm just left with x. When I divide this by 4x squared, 12 divided by 4 is 3, a minus 3. X squares cancel. So this part now, since it flipped, is on the bottom, 4x squared, x minus 3. Now we have to factor this using the AC method again. 2x squared minus 6x plus 9. Multiply these two together. The A and the C is 18. I get 1 times 18, 2 times 9, 3 times 6. 18, 1 times 9, 3 times 6, 2 times 9. That's it. I'm trying to figure out. I might have typed something in wrong. I might have, because it looks like it does not. 1 times 18, 2 times 9. None of these terms add or subtract to equal a negative 6. So if that's the case, then this particular one doesn't factor. Maybe I picked a bad problem. Do I notice anything that cancels? Any top and any bottom? The only thing that cancels is 9 goes in the 9 one time, 9 goes in the 36 4 times. And then we're done. we have a 4x on top with the 2x squared minus 6x plus 9. Don't multiply everything all back together. They don't want you to do that. Then I have 4x squared and I have x minus 3, but I have it twice, so it's squared. So that's the answer that I would give for this one. So I'm just checking my records, and I did type it in wrong. So what I'm going to do is go back. I'm going to go back. Just give me a second. I'm going back. 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 It's a very tedious thing here. Okay, hang on. We're almost done. Okay, so this 2 is not supposed to be here. In the review sheet, that 2 is not there. So once again, the first fraction stays the same. The second fraction, that changes to multiply, and the second fraction flips. When I factor everything, now you can factor this on your own. Remember, x squared minus 6x plus 9. I guess I'll factor it. When there's a number, a 1 in front of x squared, this factors to 9 times 1 or 3 times 3. Well, it's a negative 6. So if I do a negative and a negative, I get a negative 6. And if I multiply them, I get a positive 9. So this factors to x minus 3, x minus 3. So the top of that factors to x minus 3, x minus 3. The bottom, remember, a 9 factors out, and that's what I get. The top, nothing happens there. And this bottom, a 4x squared comes out, and I'm left with x minus 3. All right, so now it's all factored again. Start canceling out. There's an x minus 3 on top. There's an x minus 3 on the bottom. There's an x minus 3 on top and an x minus 3 on the bottom. 9 goes into 9 one time. 9 goes into 36 4 times. So our answer is everything left over on the top, which is 4 and an x, and everything left over on the bottom, which is 4x squared. So if you notice, I didn't realize it, but there's a 4 and a 4. So those cancel, and then one of the x's cancel down here. So if everything on the top canceled, you're left with a 1. And on the bottom, do you see we had 4x over 4x squared. X squared is x times x. So the 4's cancel and x cancel, and we're left with an x on the bottom. When they cancel, 4 divided by 4, you get 1. So that's why there's a 1 left over. That's the answer to this particular problem. All right, moving on. Let's solve this problem. In order to solve an x squared problem, everything has to be on the same side. So I want to move the 132 over to that side. The way to move it over to the other side, it's a positive 132, so I'm going to minus 132 to both sides. When I do that, I get x squared minus x minus 132, and 132 minus 132 is 0. So I want to factor this using the 3-term method when the number in front of x squared is 1. All the factors of 132, oh no, 1 times 132. 2 times 66. I see another 2 factors out of there, so I'm going to say, I can use my calculator. If I do 132 divided by 4, I get 4 times 33. What about 132 divided by 3? I get 3 times 44. 132 divided by 6. 6 times 22. 132 divided by 12, I see that. 11 times 12. And I think that's pretty much it. Which one of these will add or subtract to give me a -1? Do you see down here, if I do a -12 and a +11, that gives me a -1. And if I multiply a +11 times a -12, I get a -132. So those are my factors. A +11 and a -12. And since we have x squared, we have an x and an x in front. So using the zero multiplying rule, when two numbers multiply together and the answer is 0, one of these two have to equal 0. The x plus 11 has to equal 0, or the x minus 12 has to equal 0. Well, let's solve for x. Get the 11 to the other side. And x equals a -11. Get the 12 to the other side. It's a -12, so we're going to add 12. And x equals 12. So there are my two solutions, a +12 and a -11. All right, next problem. Sides of this triangle are 3 and 4. The longest side is called the hypotenuse. There's a hypotenuse, and that's what we're trying to find. This is a right triangle. Remember right triangles. The formula for a right triangle is a squared plus b squared equals c squared. And c is always a hypotenuse. A and b are sides. It doesn't matter which side it is. So if a is a side, that means it's 3 squared. If b is a side, the other side, it's 4 squared. And we want to find out side c. Well, 3 squared is 9, and 4 squared is 4 times 4 is 16. 9 plus 16 is 25. So what does c equal? C, then, do you see, this says c squared equals 25, but I want to know what c equals. So to get rid of a square, I do the opposite. I square root both sides. Square root and a square cancel. And the square root of 25 is 5. So the hypotenuse is 5 in this case. All right, moving on. Solve this. We're going to solve this using the elimination method. You've learned the elimination method and you learned the substitution method. This is the elimination method, where you make either the x's or the y's look the same except opposite signs. Since the y's are already opposite signs, one's a plus and one's a minus, we're going to try to make the y's look the same. The only way to make the y's look the same is if I put a 3 in front of this y. The way to do that is multiply this top row. Whatever you do to something, you have to multiply the whole row. I'm going to multiply the whole row by 3. 3 times x is 3x. 3 times a -y is a -3y, and 3 times a -1 is a -3. The second row I'm leaving alone. So the elimination method is also called the addition method, because once you see how my y's are exactly the same except opposite signs, now I can add them, the addition method, add going down. 3x plus 2x is 5x. A minus 3y and a plus 3y is 0. And a -3 and 33 is 30. So we end up with 5x plus 0 is 5x. 5x equals 30. So I'm solving for x. I need to get the 5 to the other side. It's multiplying. So I divide by 5. 5 divided by 5 is 1x, and 30 divided by 5 is 6. So one of my answers is 6. I now need to find y. What does y equal? Well, I know if x equals 6, I can plug it into any one of these equations. If x equals 6, it doesn't matter which one. I'll pick the second one. If x equals 6, 2 times 6 plus 3y equals 33. You see, I'm plugging the 6 into the 6 in the x here. That's 12 plus 3y equals 33. I'm going to subtract by 12. I'm solving for y now. I'm going to subtract by 12, subtract by 12, and I get 3y equals 33 minus 12 is 21. And then divide by 3, y equals 7. So this answer is x is 6, x is always the first number, and y is 7. There's my solution. X is 6 and y is 7. That's solving using the elimination method. In this problem, it says solve also. It's very similar to the last problem, except we're going to use the substitution method for this one. Why? Because I notice x equals something like this. When x equals something, you can substitute that x into the other problem. You see, this x is 2y plus 5. I can plug that into this x. So x plus y equals 65. If I substitute x for the 2y plus 5, do you see all I'm doing is taking this x and putting it into there. Okay, 2y plus 1y on this side is 3y. I need to take the 3 to the other side and the 5 to the other side. You have to ask yourself, which one do I take first? You always take the add and subtract to the other side first. So we're going to minus 5. 3y equals 65 minus 5 is 60. Then I'm going to divide both sides by 3. Divide both sides by 3. And y equals 60 divided by 3 is 20. If y is 20, then what plus what 20 equals 65? X plus y equals 65. And then I can say x plus 20 equals 65. Subtract 20, subtract 20. And x equals 65 minus 20 is 40. So my x is 40 and my y is 20 in this case. All right. Okay, what are the restricted values? So in this problem, it's worded a little different than you're normally used to. And you've seen this as, what is the domain? So the wording isn't the exact same, but in order to find the domain, we know a rational equation like this cannot have 0 on the bottom of the fraction. In other words, x squared minus 144, it cannot equal 0, right? So in order to find out what x equals, get the 144 to the other side by adding 144 and square root both sides. Square root and square cancel. X cannot equal, square root of 144 is 12. However, when you take the square root of a square, there's 2 possible answers. You've got to say plus or minus 12. There's actually another, so the answer is x cannot equal plus or minus 12. There's actually another way of looking at this. X squared minus 144 equals 0. You can say cannot equal 0. I always say that. And factor this. using the two-term method. We got an x here and 12 here, right? 12 times 12 is 144. So x plus 12 and x minus 12 cannot equal 0. So you say x plus 12 cannot equal 0 and x minus 12 cannot equal 0. When I get these to the other side, I get x cannot equal a negative 12 and x cannot equal a positive 12. So those are my two answers. Those are my restrictions. X cannot equal 12 or negative 12. If we were doing the domain now on our number line, right, x equals everything until we get to negative 12. And then we keep on going. There's 0. Keep going to positive 12. X cannot equal that. The graph goes up to 12 and stops, then jumps over, goes up to 12 here, and then goes to infinity here. So x cannot equal, we said x cannot equal those, so you'd write from negative infinity to negative 12, then you'd write from negative 12 to 12, and then you'd write from 12 to infinity because it stops at 12. Well, this question just says, what are the restrictive values? Find out what makes that, the restrictive values are what makes the bottom equal to 0, and these are the two answers. So it's, you had to find the domain, this is what you'd have to do, but this question is the restricted values, just what makes the bottom of the fraction equal to 0. All right, question 13, solve. So this is an absolute value. The first thing you do when you see an absolute value in a solve, you have to take everything else to the other side of the equal sign. The 4 and the 16. Oh, so of course you're going to take the 16 over. The add and subtracts always go over to the other side first. It's a minus 16, so we're adding 16. I'm left with 4, absolute value x minus 1 equals 16. Now I'm going to divide by 4 to get rid of that 4. Divide by 4, divide by 4. X minus 1, 16 divided by 4 is 4. Okay, so the absolute value of x minus 1 equals 4. So we have to set this problem up two ways. The absolute value of x minus 1 equals 4. So first you set it up exactly, because there's going to be two answers, exactly as you see it with no absolute value. And then the left side exactly as you see it, but change the sign of the right side. And then solve for x. We add 1 to both sides. And x equals 5. We add 1 to both sides. And negative 4 plus 1 is a negative 3. And we can check those answers. Put a 5 in there. 5 minus 1 is 4. 4 times 4 is 16. 16 minus 16 does equal 0. Put a negative 3 in there. Negative 3 minus 1 is a negative 4. The absolute value of negative 4 is 4. 4 times 4 is 16. 16 minus 16 equals 0. So both of these answers check out. The thing is, once you get it to this part, you have to realize an absolute value with an equal sign breaks into two parts. One exactly as you see it. The other one, the right side, the number changes sign. And then you solve each one individually. Simplify this problem. Well, this is the same as the third root of 9 over the third root of 2. You can break third roots apart. Well, you can't have roots on the bottom of a fraction. So it may say simplify, or it may say rationalize the denominator. So it might also say rationalize the denominator. This is the third power. So in order for me to get the third root out of the bottom, I have to multiply this by the third root, because you can only do the third roots. if I have 1, 2 here, if I multiply it by 2, that would be the third root of 4. But I don't know the third root of 4. I do know the third root of 8. The third root of 8 is 2, because the third root of 8 is 2 times 2 times 2. The third root means if I have 3 of something, 1 pop out. So in order for me to get 3 2's, I have to multiply by 2 more 2's, which is 4. 2 times 2. So I have to multiply by the third root of 4. And whatever I do to the bottom, I have to do to the top. So on the top, the third root of 9 times the third root of 4, they squeeze together, and we get the third root of 9 times 4, which is 36. On the bottom, the third root of 2 times the third root of 4 is the third root of 8. Well, the third root of 8, if you check your calculator, equals 2. The third root of 36, once again, is 3 times 3 times 2 times 2, 9 times 4. I don't have 3 of any one number multiplying to get it out. So it does not simplify, and we do not have a radical on the bottom. So rationalize the denominator, or simplify, means get rid of that radical on the bottom of the fraction. And in this case, that's what it takes. You have to multiply the bottom by something that gets rid of it. Since it's the third root, I need 3 2's. I have 1 here, and I have 2 times 2 is 4, 2 here. So if that was the third root of 3, then I'd have to multiply this by the third root of 9, because I have a 3 here, and I have 3 times 3. You need 3 of the same things to get it out, to rationalize. All right, the next problem looks like this. The third root of negative 125 over 64. For roots with fractions, remember, you can break them into 2 pieces. The third root of negative 125 divided by the third root of 64. So they can be broken apart. If the roots are the same, you can break them apart or squeeze them back together for multiplying or dividing. Well, 125, the third root of 125 is 5 times 5 times 5. And 64 is 4 times 4 times 4. So each of these have 3, so they pop out. Now, the third root is a negative. And it is true that negative 5 times negative 5 times negative 5 equals a negative 125. So for third roots, you can have negatives. For square roots, normally there's 2 here. That's invisible 2. But for square roots, you can't have a negative. Square root of negative 25 is error on my calculator. You can't have it. But for a third root, an odd root, third, fifth, seventh root, you can have negatives in there. So the third root of negative 125 is negative 5. And the third root of 64 is 4. So the answer to this problem is negative 5 over 4. All right, next problem. Is this a function? It's kind of hard to see. And this is the line. Is this a function? Yes or no? Remember, if something's a function, you can do the vertical line test. And if you draw a vertical line and it only touches one spot, then it's a function. However, look, if I draw it right here, it touches 2 spots. So no, because it touches 2 spots when I draw a vertical line, and you have to try to touch 2 spots. You can't just keep on drawing here and say, oh yeah, that's a function. No, it's not a function. No, not a function. So next, state the domain for this function. If I draw an x-axis and a y-axis for this problem, and your problem will be drawn there. And let's just say this is 1, this is 2, 3, 4, 5. This is 1, 2, 3, 4, 5. If you notice right here, this graph starts at 2. And the domain is what does the x value equal? So the x values start at 2. Do you see this is right here? This is the smallest x value, and it goes on. It keeps on going with this arrow goes on forever. It goes on to infinity. You can never touch infinity, so you have a parentheses. However, here, when you do domain in this particular case, it's hard to tell, but it's always going to be touching that spot. If there's nothing there, it's touching somewhere, so it looks like it's touching 2. So you have to use a bracket. I mean, if it wasn't touching 2, if it was at 2.1, then you'd put 2.1 on there. So it starts at 2 and it's touching it. So this is the correct answer. You have to make sure you have the bracket there on the 2, because it starts at 2, it's touching 2, and then it goes on to infinity. Infinity should always have a parentheses because you can never touch infinity. And we're moving. Find the value of f5. In other words, remember, f5 is just f of x. Whatever's in this parentheses, that's what x equals. X equals 5. So we're going to rewrite this function, 2 times x minus 3 times x plus 4, and put 5 into it because it tells us x equals 5. That is whatever x equals. So we're putting a 5 in here. And then we're going to do the math. 5 squared is 25 times 2 is 50. Negative 3 times 5 is negative 15. 50 minus 15 is 35. 35 plus 4 is 39. Or you can put it all in a calculator and you should get 39. All righty. Simplify. Another word for simplify in this case would be rationalize the denominator. In other words, get rid of that square root symbol on the bottom of the fraction in the denominator. It's a square root, and square roots mean there's an invisible 2 right there. So in order to get rid of the square root on the bottom, I have to multiply it to get that 7 out of there. And if I multiply it by the square root of 7, now I have 2 7s and the 7 pops out. Now, just want to make sure you understand, if you multiply this by 1, you get the same thing, right? If you multiply something by 1, you end up with the same thing that you started with. So every time you do this, rationalize the denominator, you have to multiply by 1. So if I multiply this bottom by the square root of 7, I also have to multiply the top by the square root of 7. I'm multiplying by 1. 9 times the square root is 7. The 9 is on the outside. The 7 is on the inside of the root. They can't be multiplied together. Here, square roots, if you have the same roots, you can squeeze them together and multiply. Remember, that's for the multiply and divide rule for radicals. So this is the square root of 49, 7 times 7. And the square root of 49 is 7. Now we have a 7 on the top and a 7 on the bottom, except one is in the radical, one's outside. So they cannot be reduced, and we're done. This is simplifying, even though it doesn't look simpler. It's simplifying. It's the same as rationalizing the denominator. You cannot have a radical. You cannot have a square root or a third root on the bottom of a fraction. It's okay to have it on the top of a fraction. You just can't have it on the bottom of a fraction. All right, solving a square root problem. First, we want to get the radical, the square root by itself. So our goal, same as when we did the absolute value problem. You got the absolute value by itself on one side. We're doing the same thing for the square root. I need to get rid of the 5. It's a positive 5, so I'm going to subtract 5 to both sides. And I got the square root of x plus 3 equals 0. So now we got to figure out what makes a 0. I can see real easily it's negative 3, right? Negative 3 plus 3 is 0. The square root of 0 is 0. But let's mathematically do it. We have to get rid of the radical. The opposite of square root is squaring something. And whatever you do to one side, you got to do to the other. Square root and square cancel, and we're left with x plus 3. 0 squared is 0. I take the 3 to the other side. And I get x equals negative 3. Do you see if I plug negative 3 back into the original problem? Negative 3 plus 3 is 0. Square root of 0 is 0. 0 plus 5 is 5. 5 does equal 5. So you can plug it back in and verify that the answer is correct. I think we have a few more. Let me write it like this. This is the way it's going to be written on the test. This is a fraction that has a power, and the power is a fraction. So it doesn't matter that this is a fraction, but what matters is the power is a fraction. When you have a power that is a fraction, the top is the power of the number. The bottom is the root of the number. So this is really, if I rewrote this, this is 25 to the 1 power and 4 to the 1 power. See, the top is the power. The 25 and the 4, or maybe I could even write it like this. 25, 4 to the 1 power. That it's 25 over 4 to the 1 power. But then the bottom is the root. And the root of this problem is square root. So then I take the square root of the whole thing. 25 4 to the 1 power is 25 over 4. The square root of 25 over 4 is the square root of 25 divided by the square root of 4. Remember, when you have things multiplied or divided in a root, you can break them up or squeeze them together. The square root of 25 is 5, and the square root of 4 is 2. The answer to this problem is 5 over 2. You can actually, for this problem, put that in your calculator. 25 over 4 in parentheses, raise it to the 1/2 power, or take the square root of it, and it equal 5 over 2 in fraction form. 2.5 in decimal form. Solve this problem. So I mentioned this before. Anytime you solve a problem that has an x square, and in this case an m square, you need to take everything over to the x square side. So I have a 49 that's not on the x square side, so I'm going to take it over to the other side. It's a positive 49, so I'm going to subtract 49. And I get m squared minus 16m. 64 minus 49 is 15. And 49 minus 49 is 0. So you get, if you have an x square or an m square, everything has to go to its side. It is. And now we're solving for m. We have to factor. The factors of 15 are 1 times 15. You see there's a 1 in front of the m square. 2 times, there's no 2, it's 3 times 5. Which one of these will add and subtract to negative 16 if I have a negative 1 and a negative 15 that equals a negative 16? If I multiply negative 1 times a negative 5, I end up with a positive 15. So this works. So this problem factors to negative 1 and negative 15, negative 1 and negative 15 with an m and an m first because of the m squared. So we have m minus 1 equals 0, using the product rule of multiplication. Two things multiplied together and it equals 0. One of these have to equal 0. The m minus 1 has to equal 0, or the m minus 15 has to equal 0. Get the 1 to the other side by adding 1, get the 15 to the other side by adding 15, and we have our two answers, 1 and 15. So solving with an m squared, get everything to its side and then factor if it need to be factored. If it's an m squared, it needs to be factored. Okay, so just like the square root problem we previously had and the absolute value problem, there's a couple of ways of approaching this. I like to get the square by itself because then you can square root both sides and get rid of the square. So I want to get the square by itself, this by itself. So I have to take this to the other side by adding 8. Y minus 7 equals 8. So now we're going to square root both sides. To get rid of the square, we're going to square root both sides. I'm going to square root this side, and I'm going to square root this side. Well, square root and square cancel, so I'm left with y minus 7 equals the square root of 8. And this problem is going to say solve for y. Let's take the 7 to the other side by adding 7. And 7 is on the outside of a radical, the 8's on the inside, so you really can't add them. They can't combine them, so we have 7 and a plus square root of 8. So this is our answer. However, it's not our final answer because we always try to simplify if we can. We solved, but we need to simplify. Can anything pop out of the square root of 8? The square root of 8 is really the square root of 4 times 2, right? And when you have two things multiplied instead of a square root, you can break them apart. And the square root of 4 is 2. The square root of 2 is 2. Do you see the square root of 8 changes to a 2 on the outside because the square root of 4 equals 2. So the more simplified version of this is the square root of 8 changes to 2 square root of 2. And these can't be added because this is 2 square root of 2, and this is just a 7. There's no square root of 2 with it. So they're not like terms. So this would be the answer that I would look for. Once again, the test is 25 questions, multiple choice. And I believe this is the last question. We've already did one of these, absolute value. let's get the minus 2 to the other side. You want to get the absolute value by itself. It's a minus 2, so we're going to add 2 to both sides. And we're left with the absolute value of 5x plus 3 equals 8. When we have an absolute value equals a number, you have to split it up in 2 pieces. The first one exactly as you see it without the absolute value. The second one exactly as you see it, except the number without the absolute value changes sign. It was positive, now it's negative. And then we solve for x. I need to take the 5 and the 3 to the other side. First, I'm going to take the 3. 5x equals 5. Divide both sides by 5. And x equals 1. So there's one answer, x equals 1. The other one, I'm going to subtract 3, subtract 3. Negative 8 and negative 3 is a negative 11. Divide by 5. And x equals a negative 11 over 5. So there are my 2 answers. So this was the Math 320 final exam review. If you can do these problems without any help, you should do fine on the test. Let me know how you did, and let's have a great final exam.